Welcome to our 9th recorded lesson for Computer Programming 1. We're going to talk about a couple things today that are actually a little bit confusing. We're starting on our second trip around the carousel, so we're looking at things in a little bit more depth. First, we're going to take a look at some mathematical operators, a couple that we didn't cover, and then we're going to take a look at constructors in more depth and overloading of constructors. And we'll see what constructors do, what their purpose is. After that, we'll probably go to another recording in which we'll talk about strings and string operations, which are, believe it or not, a bit confusing. I'm tempted to just not cover the confusing stuff because it is confusing, but then again, well, it's confusing and there are other ways to do it, but then again, we do have to keep in mind that many times as programmers, we're not the only ones working on a project, and many times we're given a task of working with somebody else's work, somebody else's code, and many times theirs is not made very clean, in a very clean manner, and we have to interpret what they're doing. So it's important to look sometimes at things that are confusing or things that could be done a better way so that when we see it, we'll recognize what's going on and we'll think, okay, this is what it's doing. So to start with, I'm in NetBeans here. I'm going to make just a temporary class. This one doesn't have anything to do with vehicles, but I'll go ahead and put it under vehicles. I'm going to call it Math Examples and finish. And we're going to look at some interesting things that happen when we perform mathematical operations in Java. Okay, I'm back here at Math Examples. Now, because this has nothing to do with our main vehicles project, I don't want to have any dependency between this and driver or vehicle. So what I'm going to do is I'm going to give this class a main method. And we remember what a main method is. A main method is the first method to be called when we start a Java program. So we can start a Java program in any class as long as that class has a main method. If we go back to driver, click over here to driver, we'll remember that the main method has a very specific syntax that we have to follow. First, it has to be declared public, which means it can be invoked from anything external. Secondly, static, don't worry about that yet, we'll come back to that. Third, the return type is void. A method typically does a unit of work. Many times that unit of work is a computation or a set of computations, and many times we will wish to return the result of those computations. On the other hand, if a method does not have anything to return, we simply give it a return type of void. Then we have the method name, which is main, and after that we have the string args, which we didn't explain before. But these are command line arguments that can be sent into the main method. You might not have heard a word like that before, but maybe you have. If you think about starting a program from a command line, what we used to call the DOS prompt, many times you can start a program and then give it some arguments or give it some parameters, and those parameters would come through in this parameter variable. So this main method is special. We can start a Java program with any class that has a method with this syntax, but it must have exactly this syntax. So if I go back to math examples, I want to give it a main method. One option is I could go type it in verbatim as we saw before, but I'd have to remember what public static void main. I'd have to remember all of those things. On the other hand, NetBeans gives us a nice shortcut, which is PSVM and then tab, and it will automatically give us a main method. I'm not going to put a whole lot in this method, so we'll just keep it just like this. Like I said, this is a little throwaway class. I just want to demonstrate some of the calculations and computations that are a bit tricky in Java. Let's start with one from your programming assignment. Your programming assignment number 2 says to convert Celsius to Fahrenheit and Fahrenheit to Celsius. If we take a look at the formula to convert Fahrenheit to Celsius, we take a temperature in Fahrenheit and subtract 32, and then we multiply by 5 divided by 9. This formula, if not implemented right, will always result in 0. And I say if not implemented right because we have to know how to implement it. It's a little bit tricky. So let's take a look. What we'll do here is say, let's do a mathematical equation in our head. Let's say about 100 degrees Fahrenheit minus 32. And then let's multiply it by, I'll put in parentheses 5 divided by 9. And I'm going to store this value in an int called Celsius. Okay? If we do the math in our head, 100 minus 32 is about 68. 5 over 9 is about a half. So it should come out somewhere around 34 degrees. Now I'll do system out print line, Celsius equivalent of 100F is, and we'll say use the concatenation operator, which is a plus with a string on either side, plus Celsius. Okay, let's see what result we get. I'll save, I'll right click, and I'll choose run file. What's interesting is the result that we get, let me scroll this over a little bit, Celsius equivalent of 100F is 0. We know that's not right because 0 in Celsius is freezing, which is 32 degrees Fahrenheit. So something's wrong here, but let's take a look at this equation. What's interesting here is that 5 divided by 9, well, that makes sense. If we put that in our head, that's about 0.55555. 0.55555. Here's where we have an issue. Everything we're dealing with is a whole number. 100, 32, 5, 9, and then int is a whole number. So the result Celsius is a whole number. That makes things a little bit tricky because if we divide an int by an int, Java will give us an int in return. So it keeps the data types the same. Now remember, what is an int? An int is a whole number plus or minus 2.1 billion within that range. The important part there is it's a whole number. So if there's anything after a decimal point, it will truncate that off and get rid of it. So if it has an equation that results in 0.55555, it's going to truncate or remove everything after the decimal. There are a couple ways we can take care of this. One is convert this from being an int divided by an int to make it a double divided by a double by putting the decimal point there. The problem then is it realizes that we have a double here and we're trying to store it into an int here. And it gives us a possible loss of precision error message. What that means is this time it's warning us, hey, you have fractional math happening, yet you're storing it in a whole number type. Do you realize you might lose that fractional part? So what we need to do then is we need to take this entire equation, put it within parentheses, and then use a cast operation, an int cast operation. What that will do is that will compute this all as a double. Then, once it's computed it as a double, it takes the result and converts it to an int by removing everything after the decimal point, and then we can save that in Celsius. Let's try this again. Okay, and here we go. This looks a lot better. Celsius equivalent of 100F is 37. So it did the math. It converted that all of that to a double first and then to an int when we casted it. And therefore it was able to come up with the number 37, which is just about right. Now, something interesting I found when I was recording this, and of course what you don't know is I re-recorded when I found this because it didn't give me the results I was exactly expecting. And that is this equation that I show here used to result in 0 for Celsius. It doesn't anymore. So, you know, language changes and certain things might change. Let me go ahead and run this again. We'll see this will give us the correct answer as well. This is fine. The reason being, it changes slightly the order of operations. It does this math first, then multiplies that by 5, and then divides by 9. Okay, so at this point we have a very large number up here, and that is 68 times 5. And then we divide that by 9, and then we cast to an int. In previous versions of Java, it would do this calculation separately and come up with a 0, and the whole thing would be 0. In this version of Java, what it does now is it does this highlighted equation first, then divide by 9, and then truncate, and then cast to an int. So, okay, in other words, the equation like this right now will work fine. Previously it wouldn't. Right now in this version of Java and probably in future versions will work fine. If that's the case, why did I go through all of that example that I just went through in the last 5 minutes? I went through that just to show what Java will typically do. If you are doing math with a certain data type, it will give you a result in that data type, and you have to use casting, which is just a bit confusing. The moral of the story, in your homework, this computation should work fine for you. If it doesn't, then just do what I did previously, do the 5.0 divided by 9.0. So there we have it. Bit confusing, but the moral here is that when computing with like data types, Java will return the same data type as an answer, and you have to be careful if you're expecting a fraction and storing it in a whole number type. Okay, in case I didn't confuse you there, I have plenty of chances to still be confusing. We know that I can have something say int foo equals 3, foo equals foo plus 1. And what this will do is this will add 1 to foo. If I do system out println foo, okay, plus foo. Okay, save and run. We should see an answer of 4, and sure enough we do. We know that this is a fairly frequent operation, so what I'm going to do, I'm going to copy and paste this line here. This is a fairly frequent operation, and so there is a shortcut, foo plus equals 1. That will do the same thing. That will also add 1 to the current value of foo. Okay? And so we should see the second time it prints out, foo will be a 5, because we've added 1 twice. Once here and once here. Let me scroll this over a bit so we can see the line numbers. There we go. So we see that we have added 1 to foo 2 times, so foo is now a value of 5. Well, that's handy. And one other thing that's nice is that adding 1 or subtracting 1 is a very frequent operation. So I can say foo plus plus, okay, and once again, print it out. And we'll see at this point, we add 1 to foo here, add 1 here, add 1 here, okay? And each case going to give us the same result. So I save, I run, and we should see foo 4, 5, 6, which is exactly what we see. That looks great. As a matter of fact, we can also put the plus plus, I'm going to copy this line and paste. We can also put the plus plus on the left side and once again get the same result. So I save, I run, and we should see foo 5, 6, 7. Sorry, foo 4, 5, 6, 7. There we go. Okay, if I could stop there, everything would be great. Unfortunately, it gets a little bit more complicated. What I'm going to do is I'm going to comment out the lines above. I'll keep them there so that you can still see them in the example. I'm going to comment out, save, and run again, and let's see what our current state is. Foo 4, foo 5. Okay, good. Now what I'm going to do is I'm going to say int bar equals, how many zeros did I put here? Okay, 1, 2, 3. Oh, let's just make it 1,000. We'll make it easy, mate. Int bar equals 1,000. Now what I'm going to do is say bar equals foo plus plus. This is where things really get confusing. And again, I would not use a syntax like this myself, but you're bound to see it at some point. What we have here is two things going on, and let me put a comment that says that. Increment foo by 1. Assign the value of foo to bar. So we have two things going on here. Put a comment above this one too. Init bar to 1,000. Okay. Item number 1 is we're adding 1 to the value of foo. Item number 2 is we're assigning the value of foo to the variable bar. Now, which happens first? And that's where things get confusing. Do we add 1 to foo, or do we assign the value of foo to bar? Well, the answer is it depends on where the pluses are. If the pluses are after foo, the first thing we'll do is we will assign the value of foo to bar. And then foo and bar both have equal values, but separate values, so they can be changed independently. After that, then we add 1 to foo. So let me change the statement here to say foo and bar. Okay. And think to yourself, we start foo at 3, we start bar at 1,000. We assign the value of foo to bar, and then we add 1 to foo. Think to yourself right now, what is this line going to print? Foo equals foo, bar equals bar. What is it going to put in here for foo? What is it going to put in here for bar? Foo starts at 3, we add 1 to foo. I'm going to say that should be 4. Foo starts at 3, we assign foo to bar, and then after we do that, we add 1 to foo. I'm going to say bar is going to be 3. Ignore this lower one here. We'll get to that in just a second. Okay, let me run. And we see foo is 4, bar is 3. Once again, very important. We take the value from foo, assign it to bar. After that, we add 1 to the value of foo. So in this case, foo is 4, 3 plus 1, 4. Bar is 3, 3 assigns to bar, and then after that we add 1 to foo. Bar is still 3. Okay, what's this initial value of 1,000? Absolutely irrelevant, because it's going to get overwritten with a W. It's going to get written over on line 31. So we could initialize bar to whatever we want. It doesn't matter. It's going to get changed with this assignment operation right here. Okay. Now let me do another example. Okay. And it Baz to, let's say Bugsy. Use my dog's name. And it Bugsy to 1,000. Now I'm going to say int Bugsy equals 1,000. And then I'm going to say Bugsy equals plus plus foo. So what we'll do here is we'll say increment foo with the pre-increment operator, assign foo to Bugsy. Be careful with this one. Remember I said which comes first, the increment or the assignment. This operator is called pre-increment because it's going to add 1 to foo and then after that assign the value of foo to Bugsy. This one is called post-increment because it's going to add 1 to foo. I'm sorry, whoa, almost got myself there. It's going to assign foo to bar and then add 1 to foo. So post-increment or postfix, the operator comes after the variable that it's incrementing. Pre-increment or prefix, the plus plus comes before, the operator plus plus comes before the variable it's changing. And that means it's going to change the variable first and then assign that variable to Bugsy. Okay, so I save. What I'm going to expect here is that at this point foo is 4, adding 1 to foo is going to make it 5. It's going to increment to be 5 and then assign that 5 to Bugsy. And then on this line, foo equals foo plus Bugsy plus Bugsy. What I'm expecting is these should both be 5 here. Okay, so let me save, run the file, and there we go. Foo 5, Bugsy 5. Reason being, we add 1 to foo first, then we take that value and assign it on the left to the variable on the left. So pre-increment, do the increment first, then take that value that's been incremented, assign that to what's on the left. Post-increment, do the assignment first, assign foo to bar. After the assignment, change the variable on the right. Now, as I mentioned, I really don't like this construction at all. How would I do it? I would do it something like this. Foo plus plus, bar equals foo. In this case, it's very obvious. We're adding 1 to foo, and then we're assigning foo to bar. Or if I prefer, bar equals foo, and then foo plus plus. They're two different variables. They're two different places in memory. So once we do the assignment, we can do whatever we want to foo, and it's not going to change bar. That's how I would much prefer do it. To be perfectly honest with you, I would never use this construction. I would never combine an assignment and an increment or decrement in one line. It's just confusing. It's not very readable. Once again, that being said, why do I show it to you? Well, I really like our program at the University of Cincinnati, but in reality, not everybody's going to go to University of Cincinnati. Some will go to Northern Kentucky University, some are going to go to ITT Tech or UTI or National American University and get their bachelor's degree in only 6 months. Or some of them just read out of a book. So many times the people who write code end up leaving and then you end up inheriting it and you have to figure out what they're doing. So I would never do this. But if you have not seen this before, and then you're wondering why somebody else's code doesn't work and you come across this, it might look a bit confusing. Now you'll have a better understanding of the difference between the pre and post increment. Again, I wish they just didn't let you do it all on one line, but they do. So if you come across it, this is what you're going to see. Not to confuse things more, but we can do the same thing with a minus minus. Minus minus just means subtract 1. Now we have to think in reverse. Now what we're doing, do the assignment first, then the decrement. Foo starts at 3, so we assign 3 from foo to bar, and then we subtract 1. So what I'm going to expect here is that bar is going to be 3, because that's the value before we subtracted 1. Foo is going to be 2, because that's the value after we subtracted 1. Coming down here now, foo is going to be 2. We're going to subtract 1 from foo and then assign to Bugsy. So 1 minus 2 is 1. I expect here that foo will be 1 and Bugsy will be 1, because with the pre-decrement, we do the subtraction first and then we do the assignment. Let's go ahead and run this through. My prediction here is 2 for foo, 3 for bar, 1 for foo, 1 for Bugsy. Let me make sure I've saved, and then I'm going to right click and choose run, and there we go. 2, 3, 1, 1. I can keep talking about this for another 20 minutes. Probably it will still be a bit confusing. One thing I might point you to is our class website. So I go to ucjava.com. Okay, I click on Computer Programming 1. I go to Variables and Types, and then I go to Increment and Decrement. This explains it a little bit more, but again, it's just something you kind of have to do. This is an excellent quiz question suggestion. I know I have several questions like this already in the quiz pool, so you might want to practice this a bit. When you take the quiz, if you get a question like this, remember it is an open book quiz. Might be worth your while to go ahead and do exactly what I just did here in our in-class example, and that is create a little dummy class like this, put in a public static void main method. Again, remember the NetBeans shortcut, PSVM tab. You can only have one, so you see when I do it twice, it gets mad at me. I have to take that one out. Put in a main method, run a few examples through, print out the results. That might help when taking the quiz. And again, to be honest, that quiz question, when I do give it, is very frequently missed. I have several different combinations, and it's a fill-in-the-blank question, and that question is very frequently missed. So you might want to work through a few examples before taking a quiz to make sure you understand it. And again, I wish I could just throw it away and say ignore this, but unfortunately, somebody in your programming lifetime who's not you will do this at some point, and then you'll need to go through and interpret it. Many times you'll be looking at something like this if there's a bug. Say we had a collection of items and one didn't get updated, and then you look and say, oh, I see, that's because somebody did this assignment incorrectly. So those are the important things to look for, things that you might not be expecting. Okay, deep breath here. We're at the 25-minute mark, and this material is kind of complex enough where I want to look at it just in one bite and then be able to move on to something else. I'm going to go ahead and stop the recording here, and then I'm going to make a new recording, which we're going to take a look at strings and constructors. That's confusing as well, but we can make sense of it. So hopefully that one will be a little less confusing. Okay, so I'm going to stop the recording here and we'll start talking about strings. Thank you.